Where's my coffee? There it is. Mrs. Thrower made, you know Mrs. Thrower is? No. She's one of the special ed math teachers. She and her husband, they own Sean's coffee shop out in somewhere, so that's Mrs. Thrower. She made me last year, I had this horrible, you remember I had that really bad throat cough thing that just wouldn't go, it would not go. It was for like a month straight I had this horrible sore throat cough. It just wouldn't go away, nothing would work. She brought me dandelion root tea. Yeah, it was. The amount of caffeine in it, though, was like, whoa! No! It was great! That's why I don't drink that, otherwise you guys have been like, oh, jeez. Anyway, slopes. What are slopes that you're talking about in terms of stuff?
A line on the rise over run.
Something over something. Yes, rise over run. When you're talking about rise over run in terms of x's and y's, which one is the rise? The y's, therefore, by process of elimination, the run, well, not the runs, but the, all right, the runs would be the x. Good. You guys have seen it written like this before, right? Change in y, change in x, that delta. Delta is the Greek letter that in math stands for change. Like I said, I'm pretty sure you've seen that. Slopes, obviously we're talking about ordered pairs. We talk about it in terms of sets of ordered pairs. First set of x and y values, second set of x and y values. Those numbers below the x's are called subscripts. I don't know if you've heard that, what the term was. So it's x sub 1, y sub 1. X sub 2, y sub 2 would be the technical way you should say it, not x1, y1. I had an evaluation once. You know how teachers get evaluated by administrators and you gotta make sure you're not just swearing at you all day long? You're supposed to. The appearance that they're not in there is good. I got docked because she used to be a math teacher because I said x1, y1. She said x sub 1. Okay. So, I remind you, it should be sub. If you don't say it like that, whatever, you'll get over it. Remember, you're just find the difference. And there are so many quick ways of doing things like that. And once again, what is the letter that stands for slope? M. Kind of weird. There's no M anywhere in the word slope. You know why they use the letter M? Okay. What does S look like? A 5. What does an L look like? What does an O look like? What is a P? What do they use P for in math? Perimeter probability. E, exponential. And there's another S. So now you start thinking about why they were coming up with different letters. What is A, B, and C used for? Pythagorean theorem. What is D for? Distance, diameter. E, we talk about F. F is a function. F of x, we put the, anyway, we'll get to that later.
I know that one.
G, H, those are, F, G, and H are all generally, or H, height a lot of times. G is usually used, obviously, for gravity and physics. A lot of times in math we use G of x as another function notation. I, you know what I is? No, the I is an imaginary number. There are numbers that exist that you don't think exist, but they do exist. Only in your mind. J is for, it's a variation, it's a joint variation style problem. We don't talk too much about that nowadays. K is something I forgot, it's another. Well done, nerd. And then we're back to L, and there's your line. So they had to go through all the alphabet, and they finally wound up with M.
Are there any left that aren't used?
I don't know, I just made all that up and you bought it, so.
I knew it. What about Z?
I have no idea.
Why did they use Z then?
Wait, isn't Z used for like
X, Y, Z.
X, Y, Z, yeah.
What about?
You know, seriously, I did make all that up. Most of this is true, but I don't. I think there's some guy named Murphy that made up slopes. So who knows?
What if it's the last name for slope?
All right, so real fast, we're just gonna do a couple of these. I want to ask you real fast. There are how many types of slopes?
Some, no,
An adequate amount of numbers. Okay. Yes, that adequate amount has a specific value. How many types of slopes are there? I see a 1, I see a 2, I've seen 3 a couple of times.
2.5.
2.5, no. There are integer values. They are countable. I mean, if you have half a finger, you can count it as a whole thing. There are 4 types of slopes. You have positive.
Negative.
0 slope is a horizontal line.
Oh.
And a vertical slope is an undefined slope. Because your x value doesn't change, and that becomes u divided by 0. So real fast here, you get 1 minus 5, 2 minus negative 3. Now what's really nice about your calculators, if you don't like to math, it does. Remember how to make a fraction bar?
Yeah.
Alpha, you do alpha y equals, and then just do 1 minus 5 over 2 minus negative 3, and hit enter.
Or you could do it in your head.
Or you can do it in your head, correct.
That's
But
so
if
much
you
better.
have a hard time sometimes with all the negatives and the subtractions and all, by all means, calculate as your friend. So you have a negative 4/5 slope. That just means your first step, if you were plotting something, would be go down 4 over 5. I know all of you guys remember that. Just a quick little heads up. So the types, we have 4 types. We have a slope that is positive, which means it's up and right. A slope that is negative, which is down and right. A slope equaling 0 is a horizontal line. What's the equation of every single horizontal line? It starts the same. Nope. A what? Y equals what? It could. What else could it equal? Any other number. Yeah, it's the thing here is, guys, every horizontal line always has the exact same equation. No matter what. Every one of them is the same. It's always going to be y equals some number. Doesn't matter what it is, it's just some number. 6, 0, 5, negative 33, whatever. Some number. And like you were saying, it'll always be that y-intercept because that's the y value. Okay? And then the other one is when you have a slope that is undefined. Undefined slopes occur when you have 0 in the denominator, because remember, you cannot divide by 0. Bad things, man. Bad things. And that is a vertical line. And that every one of those is always x equals some number. Ooh, $1 million question. Are vertical lines functions?
Sure.
Yes.
No.
Why?
Because you gave us that look that made us think otherwise.
Why or why not?
You need $1 million, not so it.
I got $40, which is weird. I've never had cash. Is it a down payment on your answer?
Down payment.
What's the answer? Look at the super duper answer on that one. I was just saying it's not going to pass the vertical line test, but yeah, it's good high five.
Dang, did you get $40?
No, that was just for Sarah, so deal's over. So those are your 4 types of slopes. They come into play a little bit more when we talk about writing equations. One of the things I want you to remember, vertical and horizontal lines are always what to each other?
Perpendicular.
Perpendicular. Vertical and horizontal lines are always perpendicular to each other. Horizontal lines are always parallel to what? Other horizontal lines. Vertical lines are always parallel to what? Other vertical lines. And it's a nice thing that you always have this great little cheat sheet for that on your paper. These blue lines going left and right are horizontal. Unless you turn them this way, then they are. There you go. Now, these red margin tab lines are then, but if they go this way, they are.
I don't think that helps.
They're still perpendicular to one another, aren't they?
Yes.
But
Math!
what if they're diagonal?
Aren't they still parallel?
Perpendicular to each other.
Are they still perpendicular to each other? You know why? Because their slopes are opposite reciprocals of one another.
That's why.
Exactly. No, this is why.
Yep.
Oh, speaking of, we should probably do that real quick. Parallel, you guys remember that symbol?
Yeah.
Parallel lines have same slope. Perpendicular lines have opposite reciprocal.
What if your hat is like weird?
When I say opposite reciprocal, what does that mean?
Split and it's negative.
It's flip, but what happens if it was negative?
Maybe positive.
Change the sign, flip the fraction. Okay, change the sign, flip the fraction. So if the original slope is 1/3, what's the perpendicular slope to 1/3? -3. Good. If the original slope is 0, what's the perpendicular slope? Oops. Undefined, exactly. Remember, what kind of lines have slopes of 0? Horizontal. You know why it's horizontal? What's the second letter in the word horizontal? Oh! There's a lot of stupid things I'll show you that you will be like, oh yeah, that makes sense, but it's stupid, but it's right. Horizontal line, second letter is an O. Look at that, it's a 0. It's kind of the same thing-ish. Horizontal and vertical are perpendicular, so that's where you have to put the relationship between the two. That means that your perpendicular would be just undefined. Okay? Just a quick refresher on that. We'll talk more about it in a little bit when we talk about writing equations. Good old point slope form. Yeah, you're like, oh crap, I gotta remember a lot of stuff today, don't I? Yeah. Alright. So what I like to do sometimes is find the missing coordinate. I'll give you a slope, a set of ordered pairs, but I'm missing one of the x values or the y values. So it's a matter of setting up an equation. Yeah. My English skills are something. All right. So if you have a slope of -1, you've got a set of ordered pairs. One's at x and 4, the other one's at -6 and 8. My suggestion is to write out the formula and fill in the blanks. Now, if you're fine with just the formula without having to write anything out, it's fine. Does it matter which one's your first set or your second set of x's and y's? It really makes no difference whatsoever. Normally, I just go in the way that I read it. First set, second set. I still read from left to right. I haven't done that new fancy stuff yet. Just fill in the blanks. -1 is 8 minus 4 over -6 minus x. And then, does that change anything? Isn't that just fraction equal fraction? When fraction equal fraction, what do you do? Yes, yes, that thing. You cross multiply. Fraction equal fraction is just no more than cross multiplying. So cross multiply this through. Are we okay by saying that this equals 4? I hope. Whew, it's tough. Can you get that? I'll be more obnoxious. distribute out. Pretty quick and painless. Okay. Pretty quick and painless.
You like to do this?
Do what?
You said you like to do it without the variables. Like something you do in your free time?
Yes, yes. It's usually on Wednesdays. I work on slopes because it's halfway through the week. Then it's coming. Yeah, I'm trying to. I know. Trust me, you guys know me for like a week, and I'm not really that funny, but I think I am.
And that's what makes it awesome.
I know, right? Because I just act like an idiot, and that's fine. Slopes, we okay?
Sure.
All right. Let's talk about graphing.
I don't
Now,
want
don't worry about graph paper today at all, because what I want to do is kind of show you what are called quick graphs. I kind of alluded to this during 12th hour yesterday. We got off on a tangent, which never happens, and we started talking about that wasn't supposed to be a pun, but it was kind of punny. Man, I am just full of it today.
It's only two.
making me sad.
I'm sorry. I'm sorry. Now, can you imagine if you had me for like 3 or 4 years in a row?
I bash my face into my
I had a girl for, it was going to be almost 4 years, but she wound up moving about halfway through first quarter of her senior year. But I've had kids like 3 years in a row. You know, it's bad. I mean, I'm on my third siblings. I mean, those poor people, they're just hearing stories and just, oh God. Anyway, graphs. One of the reasons we showed you guys a long time ago about slope-intercept form was that it was y equals mx plus b. The reason that we always try to get you guys to use slope-intercept forms is because we were trying to get you to remember that eventually you're going to have a calculator that said y equals. It's kind of nice. So slope-intercept form is really nice and easy. It's user-friendly. There's nothing crazy about it at all. You guys all know how to get y by itself and go from there, plot it, and walk. The form that we kind of shied away from for a long time was the standard form. And to be honest with you, graphing in standard form, more often than not, is quicker. If the problem is written out in a pseudo form of a standard form, it's a lot easier to do what are called quick graphs. And I'll show you what that means here in a second. But standard form, if you recall, was that ax plus by equals c. Does that vaguely ring a bell? It might have been a while. It's not a big deal. One of the things with that is that there were a whole list of rules and stuff that went along with it where it said that a and b both couldn't be equal to 0. They had a GCF, all of it of 1, and you had to do all that simplifying and all that. Honestly, I don't care because it works no matter what. This little shortcut thing I'm going to show you here in a little bit. The reason that I like standard form a lot is because there's going to be some problems when we get into chapter 3, when we're talking about linear solving systems of linear equations, that it's a lot quicker to put things on graphs to get a rough idea where something might occur. So with the idea of this standard form is I want to talk about x and y intercepts. And I'm just going to kind of do that. What are x and y intercepts? Yeah, it's when they cross the x and the y-axis. So if you're crossing the x-axis, is the x-axis the one that goes up and down or left and right? It goes left and right. Remember, it's the runs. It's just that poop jokes never get old. I mean, it's true. They're funny. I mean, whatever. It's just my kids. So as you cross the x-axis, as you cross the x-axis here, that is going to be some coordinate x, but what will always be your value of y when you cross the x-axis? 0. Good. Likewise, when you cross the y-axis, what's always your x value? 0. So what you're doing here is that by working with standard form, there is a very nice shortcut way to find intercepts. So if you think about what the equation was, ax plus by is c. If I'm going to figure out what my x-intercept is, that means my value of y is going to be 0. Do you agree?
Yeah.
So that basically that just tells me that I can cover that up and solve for x just by dividing by the value of a. And that gives me my x-intercept. Likewise, I do Likewise, if I cover up the x value, I can get a y-intercept. This is what we call quick graphs. Because how many points do you need to create a line? 2. There's your intercepts. And you're done. It's okay. This is a super, super easy thing to look at. Let me get to an example here. No graph paper. 2x plus 3y equals 12. I'm going to graph it. 2x plus 3y equals 12. I'm going to graph it via intercepts. Dios mío, profesor libre de español.
I got none of those.
¿Tú no hablas español?
No.
Oui.
Two.
Dora. So 2x squared plus 3y equals 12. Plot it via intercepts. It's a much more efficient way to do things. Because a lot of times in this class, we're just trying to get a quick visual. Because eventually, when we start getting to whole systems, we're going to be doing systems of inequalities, where you're going to be shading things. And our graph lines just need to have intercepts to know where things are going through. And this is a super easy way to do it. So if I cover up my y value, what's my x-intercept? 6. And I'm just going to write that, 6, 0. If I cover up my x value, what's my y-intercept? 4. There's your line. You don't have to get it into slope intercept when to do all that.
Why have we been doing that all this time?
Because we can't put that in the graph calculator.
And I get that a lot. Why didn't you see this before? This is stupid. Why did you do all this work?
Oh, no, it's
And really, and honestly, back then you had to manipulate some stuff through. There are ways to figure out what slopes are from standard form. I think it's the opposite of b over a would be your. Bless you. Is that right? No, it's opposite a over b. Excuse me. I forgot how to math. Because if you move it over, the a becomes negative, and then divide by b. Yeah. So anytime when you're in your standard form, your slope is always going to be the opposite of a over b. Just in case you ever wanted to know that. And you can kind of see you went down 4 over 6. Negative 4 over 6 is negative 2/3. There's shortcuts all abound. And I'm sorry that you were never shown that. They gotta save some for the cool teachers. So wait till you get Fontana. That's picking on myself.
Oh.
Well, you know, I must apparently owe you money. It works the same way with negatives. It does the same. Also, what's really nice about this is that eventually, when we get into the larger graph style problems, we're going to have standard form equations. They're going to have intercepts of like 100. But do you have to go count it all the way out there? No, you put a dot, you say what it is. That's what you're doing. That's what these graphs need to look like. You're just putting a dot, you label it, and that's good. It does not have to be precise. You are just getting a rough idea of what something, a visual representation is. And that's kind of weird for a lot of you guys to think that you can just do that without having to count and make sure everything's pristine. And a lot of times, we will do that. We will. That's when we get the trig. Trig graphing is awesome.
I don't like
What's that?
I don't like trigonometry.
Well, you're going to be in trigonometry for a long time in the second semester.
I think the worst thing I've ever done in math was the proofs.
Proofs, yeah. Now, I'm not going to lie. There are a little bit of algebra. There's trigonometric proofs second semester, but it's more like a puzzle. It's not like
I like puzzles.
it's a lot of stuff. It's all direct substitution is all it is. X-intercept at
What?
2, y-intercept at
Negative 3.
I wrote it
Good at math.
and then you map. Okay. I'm assuming I probably don't need to show you an example of how to graph something that's already in slope-intercept form. I hope. I know, but I'm gonna hope.
Sure.
I'd say hope springs eternal, but the Cubs won the World Series, so it doesn't matter anymore. It's crazy. Hey, what happens if you have a slope of -2 and oh, we don't get to do this. I'm not giving you graph paper. Never mind. I'm trying to think what else I got. Do. Nope. Nope. All right.
Hey, next thing.
Like I said, we're gonna kind of go through a few of these. I don't know if we'll get to parallel perpendicular today, which is fine. No big deal. When you write equations of lines, you need to know a couple. Personally, I always like to write my equations of lines and have them finish in slope-intercept form. The reason I like to have them finish in slope-intercept form is because there's a y equals button. Okay? There's nothing wrong with standard form, but a lot of times if you try to write something into standard form, it gets to be messy. Point slope form is great, but if you just move the one value over, you're already done. Excuse me. So a lot of times you'll see write the equation of a line into slope-intercept form when you're done through. So let's remember, what is slope-intercept form? Well, we did slope-intercept form, I'm sorry. So that was y equals. What's point slope form? Remember that one?
That's a very good question. Why?
Let me guess. There's a point and a slope in it.
That seems about right. Yeah, the one I don't like.
This form is super useful because you can write any equation if you know the slope and you know a point. You can write any equation if you know 2 points. You can do a whole bunch of stuff off of that. Okay. I'm going to stop. I'm not going to go through all this. There's no reason to go further for right now. What I want to do is because I need about 20 minutes to finish out all of the stuff that's in this, and I just don't think there's enough time, and there's no need to fly. But I made a little sheet. Yeah, we'll use this for a couple of days. Yeah, but we're not doing all of it. Plus, I hope you like where you're sitting, because I'm just going to make a seating chart. That way I can learn everybody's names, because I've been pretty bad about it so far.
My name is Steve. Steve Park. Sure.
So, let's see. Let's do this.
It's enough for the rest of us. I already started doing the stack.
All right, hold on.
Excuse me.
How many classes of this do you have?
2.
That's too many.
Okay. Yeah, I've got first and 12th.
Oh, that's
Nice. So on the 2-3 side, all I want you to do is this middle chunk where you're just finding intercepts. Yes, you'll have to move some stuff around. You might want to throw them into that standard form by just combining like terms. And then those two problems at the very bottom that says solve for chance, just that missing slope thing. That should be enough. Because if you can find the intercepts, I know you know how to plot the graph, so why should I make you graph it, right? So we'll just do that. Does that sound good? Tomorrow we'll work on writing equations with slopes and points and all that other junk on the back. So we'll get there. No rush.